Hey, anybody here? Just going to go live here and just need to let people know that we're actually online. We have a whole one person watching. So let's see. Hello, everybody. Just letting the letting our peeps know that we're going to do a live stream here quick. Hope everybody's having a great Friday. How's everybody doing out there? Everybody good? Just going to put my phone on silent. So here we are. Let's see what else. What else do we got? We got LinkedIn. I don't think I let it do the preview properly. Let's try that again. There we go. Hopefully I won't mess this up. I've been struggling with my next thing, so I thought let's live stream some of my struggles. Because people always show the good things about when they're coding and not necessarily the times when they're working through the tougher problems. So let's see, have I done everything? I think I've done everything. Okay, cool. So let's go. I'm going to do this pop out window here. Pop out, just so I can kind of keep up on the chat with everybody. Yeah, so been working on this synth the past couple days. Well, past couple weeks actually, but I've been really putting some work into it. Past couple days, I haven't been sleeping very well. I wake up, been going to sleep at like 10 o'clock and waking up at 1. And now rather than Twitter surfing or just going through social media or watching YouTube, I've actually been popping open the laptop and working on this synth, and it's been a lot of fun. It's been great, but there have been some challenges for sure. So I'll show you where I'm at right now. Right now we're just building in standalone mode, and I'll talk a little bit about where I want to take things next. So this is where we're at now. So we got, I can't really play it because it's in standalone mode, but got sine, saw, and square oscillators. We've got low band and high pass filter using the state variable filter class in JUCE. And we've also got FM. Yeah, so I've done some FM as well. Got a little pitch that we can pitch things down or up by semitones, and you can do gain as well on each one of these oscillators. We've got a envelope that controls the overall signal. So that's where we're at. Yes. So this is on GitHub. Hold on. Let me share the link here for you. And GitHub, if you'd like to follow along. So I will put the link to the GitHub in the chat. So let's find it here. So here we are. And this is it here. So actually, let me just do a really quick commit just in case I've done some things that I haven't pushed to the repo yet. So let's take a look here. So git add commit. So currently I'm thinking a lot about LFOs and how LFOs are going to work their way into this synth. And so that's what I'm going to put as my commit on LFOs. Git push. Yeah, so let's see. Where to start? I guess maybe I could walk through some of the things that I've done recently that are outside of the scope of the tutorials that I've done. So, just take you through that. And because this is following the synth tutorial. So if you've been following the synth tutorial series that I've been doing recently, this is following this, but it's actually much further along than what we've actually done with the tutorial so far. And I'm starting to think that this tutorial series could actually be about 50 tutorials if it needs to be. This thing can just keep going on and on and on. It could really turn into a big project, but I'm really enjoying it. Third-eyed artificial intelligence asks what library for the UI. So this is just the standard. This is just a standard JUCE UI. So I've just used standard JUCE stuff. I haven't actually even really customized anything. John asks if I can walk through the LFO or through the FM functionality. Yeah. So let's see. Where shall we start? Maybe we'll start with just what I've done with the UI, how I got the UI to look like that, because that'll take a shorter time, and then we'll look at the FM functionality. And I hope it's okay, because I'm starting to think that there are some things that I might want to refactor. So let's see. So basically, I have these data. So I have all my classes divided into two subcategories: data and UI. So this is a principle that I've learned about over the past year, I guess, where it kind of follows along if you've ever seen any of the introduction tutorials to plugin architecture, where it talks about separating the UI and the processor sides of your of any of your plugins. So you have the UI, which is what the person sees. You have the plugin processor, which is the data side. And so I'm following this same principle for all my other classes. So a lot of these, I'll have a data class, for instance, like an ADSR data class, and then I'll have an accompanying ADSR component, which is what the user sees. Same thing for the filter, same thing for the oscillator. And then what keeps everything in sync is the audio processor value tree state. So, which is right here, looks like a big long list of, so this is all the parameters that a user can adjust in the synthesizer. And that's what keeps everything in sync, because you have this issue of when the user changes a parameter on the UI, how that's relayed to the data side. And just if you try to do that manually, it's a real pain. So luckily, JUCE have this audio processor value tree state that actually kind of magically in the background keeps all of this in sync and makes sure that you're not encountering any data races and things like that. Another reason that I keep data and UI separate is because you want to have the UI influence the data, but you don't want to have the data influence the UI. So your data classes should not be making changes, or maybe I should say, so it shouldn't really be making changes to what the UI is doing. There are times where it's meant, you would want it to observe what your data class is doing, but something like a level meter, you'd want to observe what the level of the gain of your output is, and then you have to somehow relay that back to your UI. But the thing is that you don't want that to be an important. You don't want to have a situation where your data class is relying on something that's happening in your UI. That was a lesson that I was learning even more just today, thinking about it, because I was having this LFO problem. And the thing is that when the UI isn't visible, what happens is that in code, it doesn't actually exist anymore. Your plugin editor doesn't exist. So you can't have anything that's happening in your UI that your data classes are relying on. So that's why we've got to separate out the data and the UI classes. So going back to what I was saying about the UI. So this is pretty simple. So the thing is that building something that looks nice and clean and not too complicated actually isn't too hard. So what we have is, for instance, this is the ADSR. So this is just this particular component right here, and we have just fill the background with black, set the color to white, and draw a rounded rectangle, which is what I've done. So what I've done is I've set the bounds of the actual component, and then what I've done is I've drawn a rounded rectangle 10 pixels within the bounds. So the bounds of this actual component is actually 10 pixels wider than that rounded rectangle. So it gives that nice little bit of space between each one of the components, which is really cool. And you can see that I've done that with bounds to float reduced 10 pixels. So that's how we do that. And then you just simply set the name of the component. In this case, it's envelope, and I've drawn that in yellow. So that's how I've done the components. Yeah. So that's to answer the question about components. Now to talk a little bit about how I've done the FM. This is something that took a little bit of thought, because FM is, for people that don't know, is frequency modulation. So you're going to have something. So I have an oscillator class. Where is it? Right here. So I've created an oscillator class that inherits from the JUCE DSP oscillator class, because I wanted to add some more functions to what it was already doing. And this is just a sine. This oscillator, it starts off as a sine wave, but you can turn it to a saw or to a square wave. And so now what was I doing? So let's take a look. So the thing is that you're going to have in the oscillator class, you would have a function called set frequency, right? So when the person hits a key or a person hits the MIDI input, then you would have set frequency, right? So what happens is that you get what MIDI note the user pressed. And the thing is that is happening when at various points in time. And what you have to do is then you have to get your FM modulator, and then what you have to do is you have to route it back in to the frequency, to the space where your frequency is actually happening. So that just took a little bit of time, because what happens is that what you have to do is you have another oscillator, right, which is your FM oscillator. So you're using one oscillator to control another oscillator. And then what I have to do is in my audio callback, you have to find out what the phase or what the level of your FM oscillator is at one particular point in time. And then what you have to do is then you have to feed that back in to where you're setting to the function where you're setting the frequency. Thing is that you would like that to be in the same place, but because you could be setting your frequency at various points in your signal in your workflow, like such as when a user presses a key, you have to have a separate place where you actually place the FM, the modulator, and you get your modulator frequency and your modulator depth. So I could actually show you what that looks like. So let me just build that. So where am I creating my main window? So that's in the plugin editor class right here. So plugin editor is kind of our parent component, and I'm doing that here in set size. So there's the size of the main window, and then in here I'm setting out my UI. So I have oscillator 1, oscillator 2, the filter, and the ADSR. So let's take a look here, and I will show you. Hopefully this comes through through my actual live stream. I'm not sure if it's actually going to come through. Can you hear that? I hope so. So you got gain, you got pitch, then you got FM frequency. So you can actually double click here and it'll take you back to, what's going on here? Then you got FM frequency, FM depth. So there you go. You also got your low pass filter. Resonance. hopefully this works, my bandpass. And then high pass. And then ADSR, so switch this back. You can do release. Stuff like that. So yeah, so that's basically where we're at right now. Then of course you can add the second oscillator as well. So let's just pitch this down maybe. It's 24. Cool. So that'd be cool if we were making like a sci-fi movie or something. Yeah, so that's what I want to do. I want to now try to create an oscillator that's going to control this filter cutoff. So that's the next thing that I'm really thinking about. But yeah, that's pretty much it. That's pretty much what we got so far. Quite a bit that we've had to do to get it to this particular point. Yeah. So now comes the next part where we're taking a journey into the unknown, and thinking about how to get this LFO, how to get this oscillator controlling the filter cutoff of this filter. And this video will be up after after we're finished as well. So you can watch back on this. John was asking about that. Yeah. So, so let's see. So what I'm thinking. So one of the things that I was thinking about was, first of all, and like I said, this is more me kind of thinking through rather than having a solution. So I don't know the answer to this yet. And I'm hoping that in this live stream that I can actually find the answer or work through to the answer. So in some sense, you have a number of envelopes and LFOs that you can actually take, and you can actually drag and drop them on various bits. So you could drag and drop it to the gain or to the pitch, to your filter cutoff. I've always wondered how they do that. So I thought that maybe it would be a situation where, like I was saying before, there's this rule that I understand that that your data is never supposed to rely on, or your UI is never supposed to rely on the data. So the traffic, the communication is only happening. The communication for things that should change in the data should only be coming from the UI to the data. So the data should never be dependent on something the UI is doing. So yeah, so it should only be observing, like things for like a level meter and things like that. So I've just been thinking about, my first approach was thinking, okay, if I created an LFO in data, so you have this sine wave that is oscillating, I thought, okay, if I take that and I just use that to control what this dial is doing, then that is kind of problem solved, isn't it? Because what's happening is that your wave is oscillating, and then it's controlling the filter cutoff of this. And then what's happening is that then your filter cutoff is, then your UI is actually signaling to is actually controlling the filter cutoff of your data. That's great, except one problem. What happens if your UI is actually closed? If your UI is closed, then it doesn't exist, and then you wouldn't that control wouldn't exist anymore. Your dial doesn't actually exist anymore. So now I'm starting to think that what needs to happen is that I'm thinking that what needs to happen is that maybe there need to be hooks or paths into the signal chain for a potential LFO or for a potential envelope, and that you just need to hook in to where that could be. And then, so something like that. That's kind of my current train of thought. I don't know. I don't even fully have that really thought out yet, how that would actually work. So yeah, so let's have a little peek into where something like that would happen. So I'm just going to pull open just a text edit here, so I can actually just kind of type in pseudocode what I'm actually thinking. Okay, so I'm thinking, let me just make this a little bit bigger for people who may not be able to see very well. So I'm thinking filter is going to have a cutoff frequency, right? So it's going to have some place where it's going to say either cutoff or set frequency, right? Now, the questions that I have are, how do I route an LFO to control the cutoff? And then on that, another question that I'm thinking about is you would have some sort of depth. So you'd have some sort of amplitude that the wave would have, and you'd have some sort of frequency. But another thing that I'm thinking about is what is a good value actually to even have for it to control the filter in a useful type of way. Because if the filter is mostly open, mostly like, let's say it's at 17,000 hertz, you don't want to have it where it would actually go past the max. That wouldn't be useful. Maybe you don't have to worry about that because the min and the max is actually set in the audio processor value tree state. So your max is 20,000. So maybe I don't need to worry if my LFO goes past that, because it'll just go to 20,000 and that's it. So, and also I'm thinking about where and how do I get the phase of the LFO into the cutoff frequency? Because ideally you'd want that to happen in one place. You don't want to have to do that in multiple places. So that is, so that's where those are the kind of open questions that I'm thinking about right now. Filter. So we have this filter data where another thing that I've thought about was that normally you would process the filter in buffer size chunks. but because you need the exact value of your LFO at a given point, I would think that you would need to do sample-wise processing rather than buffer size processing, because you need to actually get the actual single value at a particular point in time. So that's kind of my thinking around that. So let's go back to the plugin processor, where the filter is actually happening. So another thing, so this is where the filter is actually processing, right here, lines 167 through 175. And so ideally this needs to happen somewhere. No, it doesn't happen. It doesn't need to happen in here. What needs to happen is that you need to process the LFO, and then the LFO needs to be updating the signal. It needs to be updating the cutoff frequency of the filter at a given point if the LFO is active. So now where to do that? So really, it doesn't need to be. So the first question is where in the signal chain do I need to have the LFO? Does the LFO need to be in the filter class? So far, I've been thinking yes, it does. That'd be the cleanest way for that to happen. So going back to filter data, I created the LFO, and now comes the question, where does that actually need to happen? So okay, so we've done prepare to play with the LFO, and so I'm thinking that it needs to happen here. So we need to process where the LFO is at in its wave at this particular point in time. So that seems like a sensible place for that to happen, which is in process next sample, and then which is happening here in my main processor class. So I feel like it needs to be something like this. So we need to say LFO get frequency. No. So let's pull up the JUCE API here for a second. One moment. So JUCE. So LFO is a JUCE oscillator. So we need like something like get, yeah. So we need this process sample, right? So this will take the sample, and then it'll return where the phase of the signal is. The only thing is I don't need it to actually do anything to the signal. Am I thinking about this wrong? I'm not. Maybe I'm thinking about this too deep. So let's not worry about that for the moment. So LFO process sample, and then here I will put input. Yeah, this worries me because what's that going to do? What's that going to do to the signal that's already there? Yeah, it doesn't feel right to me. Yeah, this doesn't. No, I'm just gonna roll with it for now, and hopefully it won't blow all of our ears out when we actually go to test it. So we have LFO process sample. So now we're going to need to route that back into a cutoff. So I'm going to create a member variable. Let's call this float LFO output, maybe. So I'll say 0.0. Output. Really, it should be probably like, is it LFO phase? Is it, what's the phase of it? Or what's the value of it? So LFO output, we got process sample. So now I need to route that into the actual, so I'm not thinking just yet about where it needs to update, but there's going to need to be something like update cutoff frequency, something like that. So where is that happening? So we have let's see. So we have this function where we're updating the cutoff frequency. Oh, maybe it could happen. Maybe it could happen here. Let me think. Because this is where the filter params actually happen. You have the LFO where you can set the frequency and you can set the depth. Would it be right for me to get where the LFO is at this particular point and use it to control the filter cutoff? That's an interesting one. Because this would be happening. Yeah. That feels more like a place where I'd want that to happen. So maybe, okay. What I'm going to do is I am going to do a getter for this. I'm going to be able to get access to the LFO. So let's do something like this. OSC data get LFO, return LFO. And then going back to the plugin processor. Okay, I'm going to try. I don't think this is the right answer for now, but I feel like this is close. So I'm going to do something like this. Filter, get LFO. Oh, why is that not coming up? Oh, it needs, because this isn't a array. Get LFO. And then, but I don't have what the input is. Dang it. Okay. This is getting, I feel like this is getting close though. So I'm going to take this, and I'm going to pop it in where the sample is happening right here. So sample, right? And then now I'm going to create a member variable for this so I can pass it to where the cutoff is. So let me see here. So this is where we need our LFO output. So I'm just going to cut it from here. Don't know if this is the right answer. This feels pretty good. Are there going to need to be two of these because you're going to have two channels of audio? Yes, you would. Right? So is this how I do that? Oh no, I'm going to do it like this. Stood array. What is this again? So this would be a float. We have two channels, so num channels to process. This will be LFO output. Can I do this? Don't know if that's going to work. Does that set both of the values to 0.0? I don't know. I suppose I could probably look it up. Oh, that's not right. JACE is initialized. Okay, oh yeah, okay, cool. I haven't initialized it properly. So okay, so let's see here. LFO, is that right? Sorry, I'm getting all mixed up here. I thought I did initialize it. No. No, I did do it. LFO, prepare to play. Oh, did I do filter data? Prepare to play. So let's go prepare to play. Yeah, so I've done that. It's saying that my LFO hasn't been initialized. But it has. Oh, because let's see here. So this hasn't been called yet. So let's make sure. Actually, sorry, I need it up here, actually. So let's step over and then step into. Yeah, so it calls LFO prepare to play. What is up with that? Which calls this. So how am I hitting this breakpoint? How am I hitting this? Oh, it's my gain. No, I did gain prepare as well. Wait, what is? So what's not actually? So let's go back here. So it's calling process sample, and then it's calling my gain, the gain in my OS data, but I've called prepare. What is happening with that? Oh no, it's earlier than that. So let's see. So it's actually here. So somehow the LFO isn't being initialized properly. So let's go back here. Get LFO. So we got LFO dot prepare to play. This is not quite right. So let's go, because LFO is OSC data. Yeah. And I've called it there. So I'm calling process next sample, but it's saying that I haven't called prepare to play on the LFO. But I have. What is up with that? Call it right here. What is going on there? LFO.prepare to play, which in turn calls OSC data, and it calls prepare. I'm a little bit lost here on why this is happening. So the question is, okay, so maybe this JUCE oscillator. Oh, maybe it's this one that's the problem. Let's go back to prepare. No, I've done prepare. I've called prepare there. That is strange. What is going on here? Okay, so let's just console this out. So let me try this. Yeah, it's called. So what's up with that? What in the world? Have I done this wrong? Let's see. Is initialized. What is static Haskell generator? Turns. So, and then generator. Ah, yes. Okay, it's been prepared, but it hasn't been initialized. Prepared and initialized are two different things. Yes, that's the problem. Yeah, so it needs to be initialized with a wave type. That's the problem. Okay, that's the problem. So what I need to do is this. So where, no, it isn't. So I thought that was initializing it. Oh, what's going on here? Unless I'm doing, oh, it's the LFO. Sorry. Sorry, people. I will get this one of these days. So it's this. This is not initialized. Okay. So we'll just make it a sine wave to start off with. Okay. Now we should be good to go. Oh, what have I done? Oh, because it's not. Ah, yes. Okay. Because I haven't. Let me think about this. Oh, it needs to be. I need to declare a what type it is. Float. Is that right? No. Man. Okay, how did I do it in Synth voice? I made a channel for. I made one for each channel. Yeah, this is the only thing is that, let me think about this for a moment, because filter data is something that I am making into, so let me just try this. I'm going to try this for a moment. JUCE, oscillator, float. And then this will be JUCE, oscillator, float. It's going to still be some, oh, this is JUCE DSP. Just going to try to make this really, really simple, because I think I might have tangled myself up here for a moment. So LFO dot Prepare. Now, let's see if this works. Okay. So now I'm going to do set gain. Okay. It's cool. We got this. Okay. Auto, or let's do gain, LFO gain equals this. Sorry, just doing a little bit of shuffling around. I hope you don't mind. Then I need to make a float, LFO gain, set it to 0.0. Okay, so let's see if this works now. Okay, still build failed. Okay, process next sample. So now this will be, I believe, process sample, process sample. Okay, so now we got this. What's my LFO object type? So LFO object type is a JUCE oscillator, a JUCE DSP oscillator. So I think we're good now. Okay, cool. So now I got build succeeded. Okay, cool. So that's fine for now. Okay, I'll have to go back. I must have something not quite right with the way that I'm initializing my inherited OS data class, but I'll come back to it. Okay, so back on track, let's think about, so now we have, so going back to the plugin processor. So now we have the task of figuring out what the value of the sample is coming out of our LFO. And then we have to use that to modify the filter cutoff. So let's do this. So I think I already created a variable for this LFO output. So I just want to make sure that I'm initializing my my array properly. So stood array initialization. Stack Overflow coming to the rescue. This, let's see. Double braces. Double braces required. So it needs to be like this, according to, if I'm reading this properly, it needs to be like this. Is that right? Yes. Okay, cool. Okay, so now going back to the plugin processor. How's everybody doing? Everybody still awake out there? I see a couple questions. Thing is that if I don't, if I'm answering questions the whole time, I'll never actually get around to any coding. So I hope you don't mind. Okay, so let's go back here. And so now we need to say LFO output equals the output of this process sample. Oh, oops, we need this because it's an array. Cool, so now we're fine there. So what I'd like to do is I'd actually like to see what. So let me see if I'm actually giving the LFO a frequency. Yep, so we're doing an LFO frequency, we're doing an LFO depth. I'm just going to give those some values that are not zero just to start it off. So let's see, what's a good LFO depth? This is something I was thinking about. Should the LFO depth be between 0 and 1? This is something that I was not sure about. So I'm just going to try it because we just want to see what these values are going to look like. So we got 0.5 that I'll put there. And let's just make the LFO frequency, let's make it 10 hertz to start off with. And see, and then what we need to do is we're actually going to console out LFO output. So I'm going to break one of the cardinal rules of audio programming. Do not console out in your audio callback unless you actually need to make sure that so this is just testing. This is just testing to see if we're actually getting a signal that's actually oscillating, hopefully. There we go. Just doing something. So thing is that it's putting out these huge values. What's up with that? That's not what I expected to get from that. Yeah, I was expecting something between values of -1 and 1, which is interesting. So get LFO process sample. I'm going to try something here because the thing is that I don't want it to actually write anything I don't want it to actually change anything in the buffer. I just need it to iterate through and just actually I don't need it to actually put anything into the buffer. So what I'm going to do something like this. Set params, and then I'm going to copy all of this business. And then what I'm going to do is I'm going to get rid of that. And then I'm going to do a buffer.clear afterwards because I don't actually want anything in the signal. I don't want this to actually put anything into the signal. So let's have a look now. Let's see what the signal is now. Still the same. Okay. Well, I feel a little bit safer actually doing what I've just done there. So let's go back to the LFO. Starting to wonder if the LFO even needs to be in this class anymore. It's not really, I'm going to get rid of it here. And I'm just going to put it in my plugin processor. So I'm going to comment this out. Yeah, because it doesn't make sense to have it in this filter data class if all the stuff that I'm doing is actually in the plugin processor itself. So now I'm going to do this. JUCE, DSP, oscillator, float, LFO. And I'm going to need 2 of these. So stood array. It's 2 of those. Num channels to process. And then let's see here. So it'll be like that. And then I'll need to do something. I need to go up here. So now just doing some cleanup here. So we got filter.prepare to play. Then we would have LFO, prepare, LFO, channel, prepare. I need to do all this stuff to get my spec. So let me do that. Where am I? So like this. Then spec. This will change to get total output channels. So now we prepared that, and then I'm going to do LFO, initialize, and then I'm going to bring over my Lambda stuff right here. So there we go, like that. Okay, so now I've initialized it. Okay, so all of this can now just be LFO.process sample. Oops, like this. So I'm not actually getting I'm not actually putting it into the output. So don't even need to do buffer.clear. So that's cool. And then I will get rid of this, get rid of this. Okay. Now I will just comment this out. And then let's do this. So this will become LFO set channel set frequency. This will be LFO freak. We are getting there, people. LFO set depth, or no, set frequency. So so I don't need to worry about, so I can put LFO depth. So that's going from 0 to 1. And then what I could do is I could do that in my audio callback here. So I'm just going to take this. I'm going to come back and clean this up later, but what I need to do, I need to have LFO depth in here so I can actually set what the level of the LFO is. So we got this times LFO depth. Okay, so now we're going to output what these values are. And hopefully it won't be 500. If it's still 500, I'm going to be very confused. It's still really high. What is that about? And it's all positive and it's all around 250. Hmm. It's a good thing that I'm not actually putting this into actually trying to hear it, because it would actually just blow my ears out. So let's go in here and see what process sample is actually doing. So we got the input, right? So let's look at, okay, so let's take it step by step. So let's look at what the input is. All right, so let's see what sort of inputs we're getting. So it would be DVG. Oh, what am I doing, man? So sample is just going from 0 to buffer.getNumber samples. It actually needs to be this. So I need to get my right pointer back. Yeah. Oh boy, I'm sleeping today. Let's, where am I going? I lost my place just when I was getting my epiphany. S is just going from 0 to 32. Or to whatever buffer.getNum samples is. What I need is, I need this buffer get sample, then channel, then sample. Yeah, you see what I was doing there? I was actually just putting this S, which is going from 0 to 256 or 0 to 512. Oh man, I tell you. Here we go. Yeah. Is it working? All right, here we go. So now we should be getting, yes, thank you. So see, now we're getting it. Samples between 0 and 1, or -1 and -1 and 1. That is more like the type of output that I'm looking for. Right? Great. Cool. So now that's fine. Right? And this is good because this actually isn't writing into my buffer, which is cool. So I can actually put this back down here. I could get rid of all the for loop business, and I can actually just put it in this same for loop, just like this, right? So now what we want to do is we want to now use that to control what the frequency of the filter cutoff is. So we got LFO output. Yeah. Do I need 2 of them? because it's only one filter frequency that's getting getting set, right? Let's see. Filter set params, filter cutoff. What's up, Evan? How's it going, man? Good to see ya. Yeah, doesn't need. So we don't actually need two LFOs, right? I'm just going to keep it. I'm just going to keep it there just to keep it there. I'm not filtering the LFO. I'm LFOing the filter to control the filter cutoff. So we're using an LFO to take the filter cutoff and move it back and forth. Okay, so now let's go back. Let's go back here. So I feel like I'm getting somewhere now. Cool. So I'm just going to, all I want to do for now, I don't want to do the set params because I don't want to blow up the filter, and I don't know if something weird would happen, but I don't want to chance it because I've seen that. I've felt that, should I say. So, okay, so now what we want to do is we have the filter cutoff, right? Which is the value that we're getting from from our value tree state, right? And now we want to use the LFO to control the filter cutoff. Okay, so I know that I don't need two LFOs to do that, but let's just try this, right? So let's do LFO plus equals filter cutoff. Can I do that? Why? No, it's saying no, you can't do that. Why? So I got LFO. Oh, LFO output. Sorry. LFO output. So now we want to see what the filter cutoff would be, right? So let's do DBG filter cutoff. So we just want to see, we aren't actually, we've kind of turned off the filter for now. Ooh, see that? Okay. Oh, of course, because, so it's just staying static. Okay. So nothing is happening. Nothing is happening. Okay, so let's go back. So let's look at what LFO output CH is. Okay. So it's not really doing a whole lot. So we can see that it's oscillating. Why is the value so high like that? What's going on there? Oh, because I'm doing this. Should it be filter cutoff plus equals? Sorry. I need to do this. Filter cutoff equals LFO. Oh, my mouse my mouse has died. All right, let's try this again. Plus filter cutoff. Okay, so let's try this again. Filter cutoff. Yeah, I was adding to LFO output, not adding to filter cutoff. So it's the first one that actually gets added to. Cool. It's oscillating, right? Nice. Fantastic. So we can see now I'm changing it, and it's going between, 15 and 20 hertz. Not really a big difference, right? Let's just change the depth. Let's just change the depth a bit. And no, it's not the same. It's not the same thing. If I do this, right? So this LFO plus equals filter cutoff is not the same as this. Filter cutoff plus equals LFO output, right? We know that it's we know that addition is, what's the word, commutative. You can switch. I don't know why it's not working like that, but basically what's happening was that it was adding to filter cutoff, and it wasn't. No, it was adding to LFO output, not adding. The final result wasn't the filter cutoff. It was the LFO that it was adding the filter cutoff to, rather than adding the filter cutoff to the LFO. Get what I mean? So let's, yeah. Filter cutoff. Okay, so anyway, going back. So yeah, so now it's oscillating, right? But now we see that the depth of it isn't quite right. We need to go back up to our depth. So where's our depth at? So LFO1 depth. I have it at 5. Let's just see what happens if I put it up to 10, how much it changes it. So I'm just trying to get an arbitrary kind of max that it should be doing. So let's see here. So yeah, so it's doing, roughly 10 hertz, right? So really this needs to be something like 5,000 maybe. So let me try that. This should give us like 0. So what's nice here is that when it's at the very top, we see that it's not. Oh, this is surprising. I thought that it was going to be, yeah, the frequency is up to 20 hertz. Oh, the depth. Yeah, I was thinking that the depth of it was going to give me a much bigger range. Sorry. I got something wrong. I'm getting there though. I am getting there. So let's make this 0 to 1 again. So let's make the default for this 20. And now let's see where we're going. Okay, so let's turn the cutoff down. So it's not really, it's still not changing the frequency cutoff that much though. It's only going between like 529 and 531. Should it be adding or multiplying? Let's just try multiplying very quickly. Okay. Oh, it's kind of blowing up the filter. Okay, so now, okay, so that was extreme, right? So it's doing this on a sample by sample basis, right? So what are we, so let's stop for a second and let's think about what are we trying to do, right? What's the desired output? So let's say that the desired output is that the filter is currently at 20, right? Let's say that at some point the filter is at 20 hertz. Let's say that I want that to go to 500 hertz, right? So we want to go from 20 to 500, and we have some type of LFO value that's in between, not Lu, LFO. So then, I mean, that would be like roughly, it would need to be roughly 200, right? You know, that would bring you to 400, you know, so like that would bring you to 400. So it'd be 250. But yeah, somebody, so it's bipolar. Yeah, so this is, yeah, so it needs to, so we got 20, oh, it needs to go to 25. 2 times 20, 20 times 25. 20 times 25 is 500, right? Oh man. I'm embarrassed because my math, you know, you're testing me on my math right now. So let's see here. 25 times 20 gives me 500. Okay, so you know, if we said that it's 20, so somebody else made a great point, which is LFO stands for low frequency oscillator. So really it should be going from 0 to 20 hertz, right? So we got this 20 hertz, right? It's at 20 hertz. The LFO is at 20 hertz. The desired output is 400 hertz, right? So that feels, yeah. So what is going on there, right? But this is taking this is going sample by sample, right? So, so I'm doing the filter cutoff, which is the filter frequency. Oh, somebody's going to give me an answer here. Rob, LFO LFO times the LFO depth. Yeah, but I thought that's what I'm doing. LFO. Oh, it's not. Hold on. This is going between -1 and 1. It needs to be the frequency, not the output. It doesn't need to be the output between -1 and 1. It needs to be the frequency. So it'll be LFO dot get frequency. Get frequency. And I don't think that I need to have two. I don't think that I need to have two LFO channels. Probably just need one. So this should work now. Uh-oh. We're close though. So let's see what the LFO get frequency is. I haven't actually set a frequency. So it's 20. Oh yeah, it's 20. And the filter cutoff. But hold on. Okay, so but the frequency is always going to be at 20 hertz, right? The problem is that we have two things, right? We have the phase of where the LFO is. No, it's not LFO get frequency. Yeah, so I was right. I was right before. So LFO output times the filter cutoff. So let's look at what LFO output is. It's because you're changing the source filter cutoff all the time. But isn't that what we want to do though? Right? So this should be between 0 and 1. We need to get, so shouldn't it be filter get, no, filter get, filter get cutoff frequency. I think it's cutoff plus the modulation. See, that wouldn't make a difference. So the fact that the filter cutoff is always staying the same is the way it's supposed to be. Man. The filter cutoff should have a base value that the LFO gets temporarily added to. Then the LFO oscillates around the cutoff frequency. Yeah, but I thought that's what it's doing, right? So the filter cutoff, if the filter cutoff is set at 20 hertz, so let's go back here. So the filter cutoff is set at 20 hertz and the LFO is at 20 hertz. But see, we got two different things, right? We got the frequency. So we're doing apples and oranges, right? We've got one that is the frequency, and we've got one that is the value of the output at a given point. That to me feels like the problem. You know, so what we're doing is we're getting the value of a sample at a given point on one, and we have the filter cutoff, which is in hertz. We need hertz and hertz, right? Yeah, mixing LFO frequency and cutoff frequency. You want to be able to change the cutoff frequency in the UI. Yeah, but you can't do it. You can't do that to the UI, because if you close the UI, then the UI doesn't exist anymore and it would stop. It would stop doing it. It would stop, you know, because your dial doesn't exist anymore. We're close though. And the fact is that if the LFO is at 20 hertz, you know, the thing is that we need the value. Let me think about this. We need the value of the filter on a sample by sample basis. Or no. Let me think about this. Yeah, you need the value of the filter on a sample by sample basis, because you need to change what that is with what the LFO output is on a sample by sample basis. Right? So what do we got? What do we have for our filter? So state variable filter, state variable filter. Okay. Process sample. This is it. This is what we need. Needs to be process sample, and then this is close. This is close to what it is, to what we need. Sample input. So yeah, so the LFO output, yeah, but that's what I'm saying is that you have to get the thing. The problem is that the problem here is that we have the LFO output at one particular point in time. what we need to do is we need to find out what the filter cutoff is at the same point in time, right? You know, this is just something that's static, that's just staying, it's just staying at 20 hertz or whatever the filter is. So what we need to do is we need to actually change both things at the same time. So we need to go back. We need to go back here, right, into our process block. So it needs to be, so we got the LFO output. Then we go process next sample. So we need to do something. We need to do something in here. How is that going to work? Dang it. Nearly there. Nearly cracked it. So the filter. Yeah. We need to get the sample from the filter, and we need to use, and we need to put the LFO output on that. Yeah. Yeah, exactly. So we have, so the question is it that, so it's LFO process sample. Okay. This is a crazy solution, right? This is a crazy, I don't know if this is right or not. But what if you did this? Output LFO process sample. What about that? Getting the next sample of what it is, and then you're applying an LFO to that. Yeah, unfortunately, Faust wouldn't help. Let's take a look at what output S is. So let me get rid of this. Sorry about my dog freaking scratching. Yeah, I just want to make sure this output is actually okay, let's try this. You're taking whatever the next sample is, and then you're okay. Sorry for anybody that was wearing their headphones. This isn't quite right. This is towards what we need though. Yeah, because this is just taking it and applying a really slow sine wave to it. Okay, I'm nearly there though. Nearly there. So Toast, stop. Okay. So the question is, do we want to get the sample at a given point, apply the LFO to the sample, and then filter, and then put that into the filter? Is that right? So it's not quite this. Something like that though. Something like output S equals this, and then this. Okay, just gonna turn my headphones down. Turn your headphones down just in case things always get dangerous when these okay. Okay, so no, that's not quite right. Still not right. Okay, so let's go back here. I mean, we all know inherently what the solution is, right? I'm just trying to figure out how to actually get it, because the thing is that I need to get the result of the filter, and then I need to change the cutoff of the filter at a given point with the LFO. Yeah. Yeah, I know that the solution. So I think we're all in solution. We're all in agreement, right? That the solution is this, which is filter frequency. You know, people keep on telling me what the, that the solution is this, right? Which is filter frequency plus the LFO times the LFO depth, right? Yes, we have established that, right? That is not the problem. We all know that that's what it is. The problem is that we need to figure out the conversion of, do we need to take the LFO? What the problem is that we need to get the filter value at a particular time, at a particular point in time, and then we need to use the LFO value to change what the filter value is at that one particular moment in time. You know, that's the problem. The problem isn't the equation. The problem isn't the problem isn't this, right? The problem is this. We know. So we have here are the pieces of information that we have, right? So we have, what's the frequency of the filter? So we know what that is, right? So let's say it's 20 hertz. Yes. Okay. The problem is that we need the filter at a given point. That's the problem, because I don't need this, right? Filter frequency times LFO. What I need is something like this: filter I plus LFO I, like that. That's what I need. Now the question is, how do I get filter I? That's the question, because I need the value at one sample. That's what I need. The value at, not the output. I don't need I don't need what the output is. I need to know what the filter value is at one point in time, at one sample in time. That's the problem, right? So yes, we know that the formula is this, but I need it, the form that I need it in, the actual like format that I need it in is like this: filter at time X plus LFO at time X, because I need the LFO to change what the filter is at that same point in time. You know, like this, when I do it like this, when you have this, right? Because this is what everybody keeps on saying. Oh, just take the LFO output times the filter cutoff. No, that's not quite right, because it needs to be filter cutoff at one particular time, right? It needs to be two waves, and it's two waves, and I need to change the value of each point in that wave. What I have here is I have the LFO output in the right format, right? So this is doing what we needed to do, outputting values between -1 and 1. But now I need the filter. I need something from the filter that's giving me outputs between -1 and 1 as well, right? So let's go back to, that's what the problem is. Yeah. So it's process. It almost feels like it needs to be. Yeah, that's the issue, is that it's, you know, you want to process. I mean, maybe I should look at the API again. Set cutoff frequency, set type, get cutoff frequency. Process sample. Processes a sample, one sample at a time on a given channel. but I almost feel like I need to know what the value of the filter is before I process something through it. That's the problem. That's the thing that I don't quite understand. I need to change the value of what of where the filter is at one particular point in time before I run the audio through it. Yeah. Everybody keeps saying it's set cutoff frequency. It's not. So, maybe set cutoff frequency. Okay. So, but once again, you run into the same problem though, which is that, yeah, you set the cutoff frequency, right? But the problem is that you have a frequency that's saying, okay, I want it to be 20 hertz, right? What you need points along a timeline, and you need to change each point along the timeline, right? You can't just say set cutoff frequency LFO, LFO get value times whatever the cutoff frequency is. It's not that simple, right? You can't. It's not this, right? It's not something like filter set cutoff frequency, and then LFO output times 20. That's not it, right? Because like I said, you're getting the LFO, you're getting the value of an LFO along in points in time along the wave. And what you need to do is you need to change what the filter is at that same time. And you need to use the LFO value to change the filter value at that same point in time. So it's not just, taking it and multiplying it times the filter frequency, because that doesn't quite work. It's, let's dig into the guts of process next sample, right? So let's jump in here really quick. So you got process sample. So, okay. So I'm not a DSP person, right? But this is what I think that I need. I need this value right here. And then I need to change that value with the value of the LFO, right? You're doing all of this, input value, so on and so forth, and you're getting a result, but then you need to apply the LFO to that one number at that particular point in time. Yeah. So let's see what Rob has to say. Let's see what Rob's solution is. Oh, sorry. Didn't get that quite. I'm not. Is it public? Is it public, Rob? Because I'm not seeing it, man. Yeah. So the problem is that we need to get the sample at one particular point in time. So it needs to be process sample, and then it's returning. Yeah. Why didn't it work though when I did this, right? Which was, filter. Yeah. Man. Hmm. I don't know if you can actually do it with the way that the filter class is set up. I don't know if it's actually possible. Hmm. Maybe if you get the output, and then you multiply it by the LFO, maybe. Okay, so let's try that. That still doesn't feel right though, because it's not changing this, it's not changing the cutoff. Man, what is going on here? It's so funny because this is going to be one of these things that you're going to look and you're going to say, once you get to the solution, you're going to say, oh, it was obvious that it was like that. See, I thought it would have been like this. Something like that. Yes, Rob, I know. I know, dude. That's what I keep saying. Yeah, but how do you get what the value of the filter is before you've actually processed the sample through it? I thought it was this. I am doing it. What the heck? Oh, wait, what about this? Okay, I got it. What about this? What if we did this? You're going to have, what if I said, Oh, Matt. What's up, Matt? Matt's going to save us. What am I doing wrong, Matt? See, Matt does everything manually, though, so I don't know if he's going to be able to help us. Okay. Here's the situation, Matt. Okay, so I'm trying to use an LFO to modify the filter cutoff, right? The problem that I'm faced with is that we get the value of the LFO output, right? So let me go back up here. So we have the LFO output, we process the sample, and we get some type of output, right? Now the problem is that I need the filter value at that same point in time so I can adjust where the filter cutoff, what the filter value is going to be for the same value, but I don't know how to get what the value is. I don't know how to get what the value is. It feels like it's this, right? Yeah, you need to change the filter cutoff for every sample. But how do I take the LFO value and adjust the sample of the filter at the same value? You have process next sample. You know, yeah. But how do you get? I would have thought that I needed to know what this value is at one particular moment in time. And then use the LFO to change what that is before it goes to the output. Or am I just missing something completely? Save us, Matt, because I'm stuck. Yeah. So like output. So it shouldn't be writing to the buffer yet. It should be something like auto sample equals filter, process the next sample. Oh no, his internet's bad. Sorry, man. And now we're getting the sample at one particular point in time. Yeah. It's not. Yeah, so I'm trying to get the LFO controlling the filter cutoff. And what I've done is I've got the value of the LFO at each sample, and I'm trying to use that to control what the filter value at the accompanying sample is. because it needs to do it on a sample by sample basis, right? I'm not doing it quite right. I'm not doing something right. Shouldn't it? So like let's have a look here. So I'm just going to do this. Filter get frequency, get cutoff frequency. So it's just staying at 1,000. We need to set. We don't need a. Yeah, we don't need a processing chain. So the filter. So okay, I think I'm starting to feel like I might be wrong here with what I was saying. So let's go back. Let's go back a couple steps. All right. So I'm just going to do this so we don't have an output just yet. Because it's the frequency that we're, we don't, yeah, we do need to change what the value, we were close, right? So we were doing something like this. So we were pretty close with this. Let's go back to what was working before, which was that filter cutoff is LFO cutoff at a channel times the filter cutoff. And then we were saying, okay, what is the filter cutoff? This is what got us to the closest result so far. So it's not quite right. So so we don't. So let's go back to what filter. So our frequency is 20. Our depth is 1. So we had something that was. Let's look at what our LFO output is. So yeah, so we got something that's oscillating between -1 and 1. So that's fine. All right. So now the filter cutoff. The thing is that yeah, so this is oscillating between -1 and 1. We have our filter cutoff, which is 20. And when we were doing it like this was giving us something that was a little bit more towards what we needed. Yeah, but I have, okay, so now let's do this. Oh, it's not quite right. Yeah. I thought it'd be something like this, because then this would change. Yeah, this is like, this is what we want, right? That feels like what we want. So it's actually the depth goes from, if we made the depth, because this is just, yeah, because the LFO cutoff, the LFO output is going to be oscillating between -1 and 1. But if we wanted it to cut, if we wanted it to change 500 over the course of 500 hertz, then we would want to multiply it times 500, right? I feel like we've got it. It's like if I do this, yeah, so that feels right. The only thing that worries me is when I change the value, when I'm actually changing the value of the slider or of the cutoff, sometimes you get into negative values, and that would mess things up. So maybe we need a caveat in here that says something like, if filter cutoff is less than or equal to 20, filter cutoff equals 20, else if filter cutoff is greater than or equal to 20,000, filter cutoff. Oh, there's stood clamp, right? There's something called, isn't there like something in the standard library for just clamping things down? Yes, stood clamp. You're a genius. Thank you, Matt. Thank you, Rob. So V low. So they always give you the freaking, okay, select this. So something like auto cutoff equals stood clamp, filter cutoff 20.0, 20,000 point. So what library is clamp in? Algorithm. So can I just include algorithm here? Algorithm. Hopefully we don't run into any collisions. Thanks, Jacob. That's very nice of you. Oh, what's going on? Is it not telling me? Saying no clamp in out. So I included algorithm. Is it because I'm on C++ 14 or C++ 14? Gonna do this. Might, if I pull open the producer. Where do I set my C++ version? Okay, so here we go. Let's try this again. It's 14. The default is 14 at the moment. So this might work now. I might not even need to use. Okay, let's try it now. It disappeared at least momentarily, and no. Okay, so now let's include algorithm again. Do I need to put it in the JUCE namespace? I don't think so because I'm just using it in the one. Okay, so no matching function call. Okay, cool. We're nearly there. No matching function call to clamp, so it's recognized clamp now. Is this like a templated function? Do I need to tell it what it needs to be? Float like that, maybe? It's looking promising. It's doing something. It's thinking about something. Yes, build succeeded. I love it. Okay, cool. So now, okay, so let's just clean all this stuff up now. So filter.set params. So LFO depth, right? Just looking, making sure that I got things right. So this should be cutoff. Just want to make sure that cutoff is actually clamping. DBG cutoff. And then this should probably go up here like this. Okay, just gonna comment this out just to make sure that we're good. So now, okay, looks like we're clamping. Oh yes. Oh yes, I love it. Cool. Now we just need to get some cool values. And so we're filtering the signal. So far we have it. I've just kept it. I turned the signal off for a moment here because I didn't want to blow up anything. So Okay. So I'm just looking to make sure everything is right here. Process sample. Yep. So, yes, so that looks right. Okay. So, shall we give it a shot? Yeah. Let's do LFO depth. So, we're going to do 0 to 500. I'm going to make this 250 to start off with. And then let's build it in VST3. Okay, so when I test this, I would advise turn your headphones down. It's always dangerous when these things get tested out. Yeah, headphone warning, headphone warning. So let's see. All right. Okay, it's initialized okay. Now I'm going to just put it down here at the bottom. Okay, I'm going to hit a key. Turn your headphones down, everybody, or take them off. Okay, I hear it doing something. Thankfully, it didn't. Thankfully, it didn't blow up my headphones. Okay, I'm going to. We don't have any. We don't have any UI controls for it yet. Sounds like it's working. So let's go back to the LFO frequency. So let's just make this like 5, and then let's make this like 1,000. Yeah, you didn't hear. You didn't hear anything. Yeah, I didn't want to. I didn't want to turn it up too loud because I didn't want to. Didn't want to mess everybody's hearing up. Okay, here we go. So we should definitely hear something this time. Okay, here we go. You're not going to see any UI feedback just yet. Can you hear that? It's working. It's working. I mean, there is some stuff that's not quite right. So, for instance, if I'm pressing the key and moving the cutoff, you can hear that it kind of messes up. It's not quite right. I mean, that would probably need to be like a linear smooth value, maybe, or something like that. Okay. By popular request, we got LFO at 1 hertz. So here we go. 1 hertz. So let's try this. How many people are actually watching this? Oh, we got some people watching. Hey, this is cool. How's everybody doing out there? Everybody having a good Friday? Nothing better to do than to sit here and work on synths on a Friday evening. Here we go. By popular demand, LFO at 1 hertz. Nice. Let's get the square wave in there. Oh yeah. We're doing dubstep tonight, baby. Nice. Sweet. Not bad. Not bad at all. Man, took us a little while to get there. Took us a while. So shall we just take a look at this and yeah, pretty cool. Okay, shall we do some shall we do a little quick class for some UI components for this so we can actually control what this is actually doing? What do you think? Shall we do that? The synth snoring. I love it. All right, here we go. So shall we do a LFO class? So I'm just thinking about this. Just thinking about whether it should be just an OSC component. The thing is that, so let me just look at this for a moment because this is an oscillator component. So I've built this oscillator subclass that might actually just work. The only weird thing about that is, yeah, I'm just going to do a separate class. If I was trying to be super clever, I would probably like subclass OSC data or something, but I'm just going to do, for simplicity's sake for now, I'm just going to do a separate LFO class. So let's do one in I'm just going to do the UI component for now, right? So let's do a component class. We'll call this LFO component, like that. I will put that in the UI. Yeah, this is everybody's favorite part, the UI aspect. Yeah, that's what I was thinking, Jas. So Jas is saying, are you going to make an LFO envelope based on the ADSR? That would be cool. I've been thinking a lot about that, a lot about how that would actually, how that should actually work, because you could have loads of different modulation sources, right? Would those be the source? That'd be the destination. You could have loads of modulation destinations. So you could potentially do the pitch of an oscillator. You could do the FM depth. You could do the gain of the filter cutoff, the envelope. Something on the envelope. So one question I've always thought about was just for every one of those things that could be modulated. Does that mean that you would need to hard code you'd need to create like a matrix or something of every single place that could be every single thing that could be modulated? That's one of the things that I've been thinking about. So if you have an LFO that you could potentially put on an ADSR, would you need to have that hard coded in where you would actually, something that, something like a mixer or something, where you have like an LFO, and then you could take the LFO and you could basically like wire it into, you would have some sort of node or some like Aldonis was saying, you would need like a graph basically to do it. So that, it's something that I've been thinking about a lot. Audio processor graph. That sounds like the solution. I've never actually used the audio processor graph. It's always looked quite complicated to me, but it might be time to actually give that class a good look, because that's starting to feel like what needs to happen there. Anyway, so let's do this LFO component, right? So I'm going to it'd be like a switch or something. Like be some sort of switch. It'd be kind of like Max MSP, wouldn't it? Where, I don't know, for anybody that's used Max MSP, where you can actually take something like that and you can like actually drag it into one of the nodes on one of your objects, and you can use it as a modulation, use it to modulate different parts of the object, which is pretty cool. I'm about to get it back into Max MSP again. I love Max MSP. Okay, so I'm just going to take some of this stuff that I did from this other class, put it in this component, in this LFO component, and I'm just going to do this. Let's see, I'm just going to call this LFO. There's a question about C-Lion. Yes, a great question. C-Lion is definitely one thing that I've been wanting to get into. One of the big things about these tutorials, of course, is that they're in Xcode. So, it's definitely something that I'd want to do for sure. C-Line would be a great one. I mean, we should just be like real soldiers and do it from the command line. That would be a lot of fun, wouldn't it? I'd love to have the skills to do that. Okay, cool. So I got font height now. So now I'm going to add LFO component to my editor. Include UI LFO component header. And now we've got LFO component, LFO 1. So I'll just say that's LFO 1 for now. And going in here. Okay, I'll come back to this. Add and make visible. Oh, that's not what I wanted to do. LFO 1. And wow, you coded Notepad? Holy cow. that'd be amazing if you did C++ and Notepad. Yeah. Yeah, Rob. When are we going to get you doing some of your Linux tutorials on here? Okay, so I'm going to need to set some additional bounds here. So I'm going to do 240. So maybe I'll do 340. So let's just see what that looks like. What's MPLAB X? What is that? Did you just make that up? That's hilarious. Okay, so we got this. I'm going to put it under the filter. So let's see if I can figure this out on the fly here. So we got LFO 1, set bounds. Then it would be filter, get bottom. Then the Y. Nope, sorry, this is not right. So it'd be OSC 2, get right. Filter, get bottom. Then the width and the height of this will be, so we'll make it 180 wide. Should I make it 120 deep? Something like this. Da, 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 da. We got something. Okay, so LFO, shall I make, just going to make the UI a little bit bigger. 390. This is going to be a beast. This, when I do things like this, I just have so much respect for whoever made synths, whoever made any commercial synth. I mean, what a project, huh? I mean, props to these people that make, like Steve Duda with Serum, like the Arturia team with what's the name of their flagship synth? Pigments. What about Pigments? Man, what a synth, right? Or like if you want to go old school, what about Massive? I mean, this is when I think about the synths that some people have created, and you think of Massive being made outside of JUCE and just, all of that from scratch, and all the things you could do with the old school Massive, with the first Massive, where you could take envelopes, LFOs, just drag them to any modulation source and change the pitch. It's unbelievable, isn't it? I mean, that is just phenomenal, isn't it? I mean, it just blows my mind thinking about the work that some of these people have put in. Props to them. We need to get some more of them on the channel. If I could find the person that did Massive and get him on the channel, or her, if it was a her, don't want to be exclusive of gender here. If I could get that person on the channel, that would be awesome. Yeah, I mean, the drag and drop on Massive is just incredible, isn't it? It just blows my mind. Okay, let's focus here for a moment. I need to make a bunch of I need to make some sliders here. So we got we're going to do modulation frequency and modulation depth. Yeah. Yeah, it's amazing. I think Massive, the original, I think the original concept, I think I heard that the original concept for Massive was actually one person. But Steve, like, think of Steve Duda with Serum. You know, it took him I think he said it took him 3 years to make it. And the thing about Steve is that he's admittedly not even a hardcore developer like that. And he did it in the raw VST SDK. He didn't do it with JUCE. How crazy is that? That is wild. That just blows my mind. He must have just not have had a life for a while. I mean, it just really blows me away what some people do. Do you? Somebody said that I have a drag and drop synth in the works. Yeah. Yeah, Laurent would be great. Yeah. Man. Yeah, some of these developers. What about Matt? What about Matt Titel? I don't know if he's still here with with Vital. What a synth, right? And he gave it away for free. How wild is that? You know? You do all that work and then give it away for free. Incredible. Yeah. That is just really something, isn't it? Yeah. Yeah. Some of the stuff FL Studio has come up with is pretty awesome as well. And wow. Yeah, they've come up with some really cool stuff. Have you seen for people that have used FL Studio, have you seen the really awesome things you could do, like splitting MIDI signals and splitting MIDI notes and things like that, like a splitter? And there's some, like, it's not the most complicated stuff, but it's really just really thoughtful, really interesting stuff that people would actually use. Their granular effect is really good too. So anyway, I'm trying to multitask here. So we need that. We need some attachments. So let's do this. Let's do Yeah, that frequency splitter is awesome. And what about Ableton? Ableton are doing some incredible things as well. I mean, they're, it's just, yeah, some of the things these developers do, man, I think that they're just incredible. I've had I've had the pleasure of of actually contracting with Ableton for a couple months. Just being around their team was life changing. It really was. Just seeing just the talent was just really influential on me. LFO freak attachment. Yeah, just really awesome. Not only awesome developers, but just awesome people as well. Just really thoughtful, really no arrogance, no arrogance at all. And it's incredible because, I mean, when I was contracting at Ableton, the Gerhard, who was the CEO, who still is the CEO, one of the creators of Ableton, he stopped me in the hall and I didn't even know it was him. And he just said, we need to meet. We need to talk. I mean, what CEO does that? It's just, yeah, wow. Still, I've told that story so many times that it still really blows me away just how humble some people are. Yeah, I try to carry that on in what I do as well. It's just, wow, just incredible. So let's see here. So we got, what's nice is I've actually started developing these kind of utility functions that help actually organize this stuff pretty well. So let's see. I should probably put, rather than copying it every time, I should probably put it in like a helper class or something. Yeah, Andrew Simper as well. Wow, Andrew Simper, what a genius. Have you seen his talk at ADC? His one on nonlinear, is like a beginner's talk on nonlinear circuitry. I mean, I had the opportunity to talk with Andrew, and once again, such a genius. Yeah, just absolutely incredible. Absolutely incredible minds. You're rubbing shoulders with them now. You're here. You're here with us. Come on out, socialize. Okay, so let's see here. So we got LFO, so we got set, slider, params. So let's see if we can do this properly. So we got LFO freak. So this should be LFO freak slider. How long have we been on this live stream? Been on for a little while. LFO freak label, LFO freak attachment. I need a param ID and I need an audio processor value tree state. Yeah, Andrew Simper is awesome. Really, really cool person. I mean, that's the awesome thing, isn't it? You see when you see people who are just really nice, they're really talented, but they're also very down to earth. And I've found more in more situations than not that that people um, are really down to earth. Yeah, really down to earth, will answer any question for you. They're just very helpful, really supportive community. You know, also, the people that are in our audio programmer Discord as well. You know, some of the people that are in there are just so mega talented. It's unbelievable. They could just really create anything. Um, so here we go. Slider params, LFO depth slider, LFO depth label. Oh no, I hate when it does that. LFO depth attachment. LFO depth ID. I have no idea how I'm going to do all the tutorials for this synth. It's literally going to take me like 20 tutorials to get people to this point and explain everything to them. Yeah, it's going to be wild. So what else? What else do we have here? So now I need to set this up in my editor. So we got LFO1. We got audio processor.apvts. Has anybody seen WandaVision, by the way? I'm a big Marvel fan, by the way. If you've seen WandaVision, wow. I'm not going to spoil it, but holy cow. It's been amazing. They really just, I'm telling you, they killed it. They killed it this series. Oh, this needs to be all caps. Okay, so now we've done that. So now we just need to draw the sliders. Yeah, WandaVision. I always find it amazing how Marvel are so good at taking characters who are maybe in the scope, everybody thinks of Iron Man, Spider-Man, the Hulk, yeah, so on and so forth. But Scarlet Witch isn't one of those characters, or Vision, that people normally think of as one of the first people that you think of when you think of the Marvel Cinematic Universe. And just the way that they've been able to develop an amazing concept around characters who would normally be kind of minor characters. Does JUCE have links to Firebase? If you search on the forum, there is actually a pretty good tutorial on how to get JUCE working with Firebase. Okay, so now let's put these sliders on our component. So I have some kind of preliminary stuff that I could do here. I'm just going to try to take these and just adjust those to our sliders. Oh, nice. What app is that, Jason? So Jason's built an app with Firebase, JUCE, and AdMob. That's cool. So now we're going to do 18. Just going to change this to LFO freak label, freak. And LFO freak slider, LFO freak slider. So let's see how that looks. Oh, nice. Hey, it's a creation, right? Okay, so this needs to be a little bit bigger. Looks good though. It's in there. It's in the zone. I'm just going to put the depth on there, and then I think we'll be. So LFO depth label, set bounds, and what is this going to be? 18. No, this wouldn't be 18. So it'd be 18 plus 70. So that would be 88. So we would need to start at 90, maybe. And then 15. Then label width, label height, and then LFO. It's already polyphonic, actually. I have 5 voices. Yeah, I have 5 voices on there. For oversampling, I don't know if oversampling is going to work with the oscillators because I don't know. I don't know if the JUCE oscillators might have already thought of that or done things to actually anti-alias. I think they may have. But also, oversampling would add latency as well, which would be a concern if you're trying to play an oscillator in real time. Not sure how that would play out. No, I do not have copies of the LFO for each voice. No. You could. At the moment, I'll show. Let me do this, and then I'll show you what we have so far. Dial size. So let's see where we're at now. Okay, so these are a little bit further apart than these are closer together. Are they closer together? No, they're fine. Okay, I just need to drop them down a little bit. And so let's see here. So maybe 20? 20 and 35. Let's try that. Oh yeah, will I need anti-aliasing for polyphony? Oh no. Well, that'll be a fun mission. 30. So let's try 30 and 45. I think we'll be fine with this. 30 and 45. A little bit more. So maybe a little bit more like 45 and 60. Yeah. Yeah, I was thinking about that. So, yeah, so you'd have to have an LFO in the voices. Okay, so this looks okay. I'm going to do 40 and 55 actually. 40, 55. So let's try this. 55. Oh, we still got some people watching. Awesome. Cool. So now I just need to make the actual yeah. Should I take this up a bit and then put the LFO in there? But it wouldn't quite. I'm going to try to do something. I'm going to try to mess with this with this setup a bit once I've done to get it looking nice and neat. So let's get the let's get this first rolling. So going back to the editor, let's do. So we need the LFO bounds to be larger. So let's try 60. Okay. I'm going to try to just mess around with these, with the UI just a little bit, get it looking nice and rectangular again. Hey, Tim, how's it going? So let's take the filter. Let's make this 200. Uh-oh. Tim's got a question. Yeah, would love to help as long as it's not too complicated. Sometimes people say, I've got a synthesizer. Can you help me make something like Serum? Yeah, so Justin, this actually uses a lookup table for the frequency for the oscillators. Okay, so you have a JavaScript project and you want to get a C++ project out of it. Ooh. Yeah, I don't know. That sounds like a tough one. Not sure that that's going to be yeah. I doubt that Tim, I doubt you're going to be able to get you're just going to have to probably port it piece by piece. I don't think that you're going to be able to do just have some type of exporter that's going to be able, or some type of converter that's going to be able to convert it like that. You're going to have to do it piece by piece, I'm afraid. Yeah, I don't think that's going to work for you. Oh yeah, nice, Jazz. Yeah, if you can help them, that would be really awesome. So let's see here. So this UI isn't quite how I would like it to be. I'm thinking that maybe we can extend these oscillator classes and then, or maybe I'll just give it some more UI and add some more stuff a little bit later. Make the envelope large. So let's see what's the envelope? ADSR is 240. So what we got? We got the filter, which is 200 plus, so this should be 360. Cool, so that looks pretty cool. That came out nice and clean. So now let's do OSC 1.setDown. So OSC width is fine, but OSC height needs to be 180. So let's try that. Hey, that looks much better. This should probably say filter LFO. Yeah. So now let's see here. So we need to go back to the processor value tree and just change the defaults for this. So LFO1 freak. So this could be from 0 to 20, and we will start it off at 0. And we will make the depth from, let's see, how far should we make the depth? 10,000 maybe? And then make the default 0. I feel like maybe we should give it like a 0.3 skew, so we get a larger range of the bottom. So let's see here. So that goes from 0 to 20. So it's pretty, yeah, so it's pretty easy to get really low depth. And then if you want to, you could go up high. Only thing is that this box needs to be larger. So let's see, what was the box size of the filter? So let's see here. Text box width. So let's take these. I think I already put them in my thing. It said text box width and text box height. Yeah, here we go. And then let's see. Oh, I was going to change the name of this LFO as well. So to filter LFO, filter LFO. Okay. Nice. Looking pretty cool. There's some extra room in these oscillators, but I'll probably change that. I'll change that at some point. Add some more cool stuff. Should we just try it out in the synth really quick? Make sure that it's actually. Oh, I think I need to set up the audio processor value tree state. No, I've done that now. Let me just make sure I've done that. Yep, so I got param IDs. Okay, so let's just try all of this now in our synth. So Yeah. Yeah. If an ADSR on the filter would be cool. That could be cool. All this cool stuff we could do with these synths. Okay, so let's see where we're at now. Okay, so that works fine. Okay, now let's just turn the frequency up. I feel like I want the depth to be a little bit more. I mean, I feel like I want it to be like 10,000 maybe. Yeah. Let's try that. We're getting some cool stuff though. So let's go back to plug-in processor. Back to the LFO depth. Let's make that 10,000. So add another 0. Curious to see how this will sound. Yeah, thanks for hanging me with me, everybody. It's really cool. This has been a lot of fun. Been a heck of an education as well. So now we'll pull this up. So let's make this a saw wave. I'll pull this down. Let's get some dubstep going. Nice! Look at this! Oh, wrong one. Ho ho! Nice. Pretty cool. Got some dubstep going. I mean, there's some stuff like this, which is that. Nice. Let's add a square wave in. Ha ha ha! What about that? Only thing. I noticed a little glitch there. It seemed like it forgot what the filter cutoff was, but maybe I could catch that at a later point. Yes, grimy. I love it. Pretty cool. That's pretty sweet. Nice. Okay. Shall we do one more thing? What shall we do? What shall we do? Shall we apply? Shall we maybe do an ADSR for the filter? I feel like, oh boy, I'm going to say this very cautiously. I feel like that should be fairly straightforward to do an envelope to the filter cutoff. Yeah, I feel like that should be fairly straightforward. Should we do it? Oh, reverb. You want? Oh, reverb. Reverb would be pretty cool, actually. Yeah. Shall we? Shall we do? Shall we do a reverb real quick? I think reverb. We could just use the JUCE reverb class, and we should be able to get it going fairly straightforward. An arpeggiator. Oh, I'd love to do an arpeggiator. That would take me a while, though. Let's do. I mean, let's do something quick. Let's do something fairly quick. So I feel like a reverb would be pretty. Should be pretty straightforward. So here we go. Process stereo, process mono. Is there a reverb class in the DSP library? Oh, what was that last one? Here we go. Reverb DSP. How do you set the size, though, of the reverb? Set parameters. Applies new set of parameters to the reverb. DSP reverb parameters. So where are these parameters? These reverb parameters. So it's a wrapper around the JUCE reverb. Oh, reverbs are tough, man. I'm gonna do some DSP stuff though. So these JUCE reverb parameters, okay, so that must be over here. So let's go reverb parameters. Here we go. Here's the class. I think there's, here we go. This is what we want. Okay, it needs to be applied. So does it have a wet dry? Oh, nice. It's got a wet and dry level as well. So we don't need to actually implement this, implement a wet dry. Okay, let's try it, right? Let's just give it a shot, see what happens. Now, is this one of these that needs one per channel? I don't think so. Process, so you do process in a context. So I think should be fine. Okay, so let's give it a try, right? So we got JUCE, DSP, reverb. Reverb. Does this need any initialization? No, so it's fine. Then we will do a set. So we're going to need some parameters. This isn't really telling me very much. Okay. So let's see if we can figure this out. JUCE, DSP, reverb. Parameters? Or is it just JUCE reverb parameters? Let's just see if that works. Oh, I need to call it something. Reverb params. I love this. This is going to be a monster. This is going to be a monster when this is done. All right. Would it make me Martin Garrix? Probably. I think that it could. So, okay, so let's see here. So in our prepare to play, we'll give it some initial params. Probably need to go and clean this stuff up. But reverb params dot. Here we go. Room size. So we got room size, damping, wet level, dry level, width, and freeze mode. This is actually a pretty comprehensive reverb, isn't it? Room size equals 0.5, I guess. Reverb params dot dry level. So we'll start it off with 1.0. Reverb params wet level equals 0.0. Reverb params width equals 1.0. What else do we got? Damping, which is 0.5. Damping. And then freeze mode. Nice. It's got a freeze mode as well. JUCE team is coming with it. So greater than 0.5, put the reverb into a continuous feedback loop. Okay. Reverb params freeze. Okay. So I feel like this needs to be its own class, but I'm just going to put it in here for now. So let's do params dot pushback. Well, this might take a while, actually. Oh man, I'm starting to get hungry. It's cool though. We're gonna be strong, and we're gonna do this. So, and then we could do reverb, set params, and then reverb params. Okay, so now I'm just going to copy these so I can actually. This is one of these things about C++ is that, man, you got to write a lot of stuff. You got to write a lot of code to get some stuff going. So we got stud, make unique. This will be a JUCE, audio parameter float. And then this one will be reverb size, and reverb size. And this will be a JUCE, normalizable range, float, then 0.0, 1.0, then 0.1, and then we will start it off with 0.0. That's it. So that's one of them. Okay. Thankfully, all of these will just be going from 0 to 1. So then we got width. Yeah, you could copy a lot of these since they're all going to be from 0 to 1, which is nice. But you still have to change the names and all that stuff. So we got damping, reverb damping. So what do we want this to be at? 0.5. We're getting there. I'll put freeze mode at the bottom. That feels like that needs to be down here. So now, so now we go to the next parameter, which is dry level. I'm excited. I'm excited to see how this is going to sound. Y'all are talking about assembly. Woo, boy. I know some people that do assembly. Yeah, that is another level right there. It's awesome. I think people who have that, I can imagine that your level of understanding for what's happening must go up exponentially when you're when you can do assembly. Okay, here we go. Reverb. Okay, so I'm going to make a function called void tap set reverb params. Now we need to get all of this. So I'm just going to copy these down here. We're going to do something like auto room size, reverb size. So let's see, reverb size, reverb width. Oh, I did 2 with width. Did I miss something? Okay. So we got size, width, damping, dry, wet, and freeze. So let's just make sure I've got all those. 1, 2, 3, 4, 5, 6. Okay, cool. Got it. Damping, dry. Size. Width. Damping. I need to get some ambience, so it doesn't sound so silent all the time. Dry. Wet. This is a blast. What a way to spend a Friday night. I was just going to play Assassin's Creed, and this is much more fun, isn't it? Yep. And then let's see. So what we would want is reverb params. Do I just want to do this? Probably don't even need to do reverb params dot set jot room size. Then this. Reverb params dot damping. Should probably just copy these, right? And then reverb dot set params. Reverb params. So we got dry, what level, dry level, freeze mode. Level. Yeah, I don't know if it's got a multi-select that you could do like that. Okay. Cool. Set reverb params. So where are our functions? Okay, here we go. Void. So I probably need to do a little bit of separation here, like this. Let's turn it into a pretty sizable code base. Cool, so I think that that's fine. So now we need to make a reverb component. So this will probably be the bulk of our work on this reverb. So let's do, where are we? Here we are. So we will create a new component class. We will call this reverb component. We will put this in here. And now we can open this up. Okay, so now we are here. And now once again, I'm just going to copy some of these things over here. I really should make just make a helper class that has all of this stuff, but I'm not going to do it in the interest of time. I'm just going to do something super quick. We need six params. Yeah, so I'm going to do size. Let's see how good my memory is here. We got size, we got damping, got width. Look at this, dry, wet, and freeze. Then once again, we go over here. Now we go size, damping, width, dry, wet, and freeze. I'll go back and I'll change those in a minute. Size, damping, width, wet, dry, and freeze. And then I'm going to change this width to 35, which is what I had some of the other ones. So now we need to just change these. Size, size, damping. In the future, we'll be able to just think of the code and it will generate it for us. Wet, wet. Yeah, do you find JUCE tough to read? Do you think so? I think I think some of the stuff can be a little bit sketchy, but for the most part, I think it's pretty. Oh, I say this having used JUCE for a couple of years now. Okay, so now we need JUCE audio processor value tree state reference APVTS, and we're just going to pipe in the parameter names. So we got JUCE string size ID JUCE. Oh, I copied that actually. Damping ID. Width ID. Dry ID. Wet ID. And freeze ID. Okay. Now we're going to go to here. I'm going to do this. Now I just need to bring my function over, some of my other stuff. Copy all this. This is stuff I'll probably need to put in a helper class eventually to keep it from copying it again and again. So this needs to be slider attachment like that. This class is Reverb component. Then what else do we got here? We've got this, the way our components is all set up. So I can just take this, copy that all here. We will call this Reverb. And then what else? What else? So now we need to just set these sliders. Set slider params. Set slider params. Now we got size slider, size label, size attachment, size ID, APBTS. Even though AVP, that I should probably just take out and just make it do a reference to it, but it's not a big deal. Set slider params. And we got, what's the next one? Damping slider, damping label, damping, damping attachment, damping ID, and APBTS. Set slider params. Then we got width ID, width label, width attachment, width ID, and APBTS. Fourth one, set slider params. What's the fourth one? Dry slider, dry label, dry ID, or dry attachment, dry ID, and that. Two more to go. Set slider params. Oh, made a mistake here. Then we got wet slider, wet label, wet attachment, wet ID, and APBTS. Set slider params and freeze slider, freeze label, freeze attachment, freeze ID. If I actually had to do all of these individually, doing all of the attachments, I think I'd go crazy. It just takes so long. Okay, so that's all good. So now we need to include Reverb component in our editor. So here we go. Include UI Reverb components. And down here, we got reverb component, reverb. And then we will need to do this, add it to our constructor. Yeah, it's the it's well known that the UI actually takes much longer than the actual audio processing. And this is just with a default JUCE stuff. Imagine if we were doing something custom, it would take a long time. Reverb damping, then reverb width, reverb dry, reverb wet, reverb freeze. Not sure if it's called reverb damping or reverb damp. So let's have a look there. Reverb damping. Just make sure. Yeah, reverb damping. Okay, cool. I mean, this looks pretty clean though, doesn't it? I take a lot of pride in trying to make the code clean as possible. So let's see where we're at so far on this UI. Decide whether we're going to put it to the right or whether we're going to put it below. I mean, there's plenty of room to put it on the right for sure. I'm almost could put it along the bottom. Along the bottom feels pretty cool. I'm going to put it along the bottom, I think, and then stretch 6 parameters evenly across the bottom. Yeah, shall we do that? So let's add, let's see, 380, 480, 580. Maybe let's do 600. And then let's do reverb set bounds. This would be 0, and then on the Y it would be, let's do OSC 2.get bottom, and then width would be, let's see, would you do get width? And then height would be 200. So let's see how that looks. Pretty cool. It's a bit large on the y-axis. Just going to tighten that down a little bit. So let's maybe make that 150. Going to bring down this down about 75. So I will make it 525. Let's try that. Cool. That feels pretty good. All right. Now to set these out. This is going to be interesting. So now we are in our resized, and then So let's see, where shall we start? Size. So just going to pull some of my kind of relationships between my sliders from one of my other classes here. Just drop it in here and then just try to figure out what these will be. So so let's do size label. We will start at what, 18? Yeah, our friend Daniel actually has a nice drag and drop UI that he's created for JUCE. It's called plugin GUI Magic. So that's pretty. That'd probably be something that could save potential time. I think he's doing some OpenGL support with it as well, which is really cool. Okay, so this just needs to be dropped down a bit. Hopefully I haven't made. Let's do 30 and 45. Building in standalone mode also makes it helpful. A little bit more. So 45 and 60. Thanks a lot. I'm going to bring it up just a touch. Yeah, just bring it up just a touch. So let's do 40, 55. Cool. So that feels good. Okay. So let's see if we can figure out. You know what? I'm gonna actually just shorten it. I'm just gonna shorten it and make it not put it all across the whole width of the screen. But let's just see how we get on here. So we got size. Now we got damping. So we got damping label dot set bounds, and this will be size label get right, and this will be 40. I'm gonna just do something here. Const auto y start equals 40. Y label start. Let's do const auto y dial start equals 55. Y label start. Y dial start. I have a feeling my my dog Toast is going to be making an appearance soon. Okay, damping slider, set bounds. Yikes. So that would be size slider dot get right. I hope this all lines up properly. Dial size. Let's just try those two to start off with. Okay, nearly. Just need to get the, oh, this needs to be dial start. Cool. Now we need width slider dry, width dry wet freeze, width label set bounds. So this would be damping label dot get right. Y label start. Label width. Label height. Width slider. Set bounds. And this will be damping slider. Get right. Y dial start. Dial size and dial size. Then we got dry label, set bounds. Actually, I'm going to do this. Probably should have done this a while ago. Just do width label, width slider. This will be dry label. Okay, then this. This will be wet. This will be wet. This will be dry. This will be dry. And then this should be freeze. Freeze. This will be wet. This will be wet. Okay, hopefully this looks okay. Boom, there it is. Yeah, I wish it would line up nicely with where the filter LFO cuts off, but it's okay. Yeah, maybe if no, I'm not going to tighten it. I'm not going to tighten it down. Oh, what if I just brought this over to the left a bit, the size? Then that would make this fit nicely. So let's do that. So let's do 10 maybe. Let's try 10. See, this is the nice thing about using these relative positions. Boom, and see that? Ooh, can I get a little bit closer? Can I do 5? Is that going to get me there? Ooh, super close, real close. Let's just try. I don't think it's quite there, but let's try it out. So, so the width, let's make it ask width. Ask width. Yeah, you could do something that you could definitely make all of this resizable. Ooh, it's just a little bit too much. maybe if I just move it just a few pixels over. All right, so let's do that. So let's see if we can move it just, would 2 be too much? Oh man. All right, what if we do this? What if we make this 5? I got it. I know what we're gonna do. We're going to make the label width 67. Let me see if I just take 3 pixels off. And then dial size, I'm going to make 67. So just a tiny bit smaller. Boom, there it is. Look at that. I need dry before wet. They dry before wet, and I thought that dry I had at 1 and wet I had at 0. So let's see here. What has happened here? Have I done something wrong? So let's see here. Ah, this is what's wrong. Dry. See, that's not what you want there. This is wet. Actually mixed up the wet and dry for sliders. Nice. Okay. So that feels so now we just need to actually run it through the in the processor chain here. So let's go back to our audio callback. So it's going through the filter, it's doing all of that. And then can I do this? So JUCE, DSP, audio block, float, and then we will make this from the buffer. And then dot process. JUCE, DSP, process, context replacing, float. Oh, I need to call this something. Block. Block. Okay. Is that right? Okay, so let's see if this baby actually works. How many people are still watching? Everybody having a good time? 23 watching. Hey, everybody. How's everybody doing? Still with me? Then we will do this. Okay, so let's set the size to 0.6. Don't know if I'm hearing any reverb. So let me just do something like this. Yeah, I'm not too big on a separate dry and wet. I'm just too lazy at the moment to actually I don't know if it's actually doing anything. I'm not hearing anything. Yeah, it's not doing anything. Okay, so what have we done wrong here? Reverb.process. So I process the reverb from the audio block. Daniel, have you checked the 80 JUCE tutorials that we have on the channel? I know what it is. I haven't called set reverb params. Set reverb params. Now, we should get it. Okay, here we go. Now we should certainly hear something. Hearing something. Boom. We got. Should I do the big release? Let's get some filter freak, filter depth. Ha ha ha! What about that? Nice. Let's get some filter freak, some FM in there. What about that? It's a horror movie. Not bad. Not bad, not bad at all. Pretty satisfied with that result right there. Now we just need what we need is I think I might call it a night for now. But I think what I might do is we definitely need to have a filter envelope, don't we? Definitely need to have one. It makes me think, actually. Okay, we're gonna do one more. We're gonna do one more thing. I said I wasn't gonna do any more, but I think this is gonna be. I think this is gonna be pretty simple, actually. Every time I say that, it never turns out to be quite that simple. But what if? Yeah. Yeah, you could definitely check this vid after we're done. But I'm gonna do one more thing, actually. Check this out. So we're gonna do. We're actually going to do another ADSR component. So let's see, how are we going to do this? Where shall I put this? Just going to put this below here. So filter, so ADSR component, filter ADSR. And then, so this goes right before the reverb component. Filter ADSR. I know this is the thing, man. It's too much fun. Now we're going to create some params. So I will call this filter attack, filter decay, filter sustain, filter release. And then we're going to do add and make visible. Filter ADSR. Then filter ADSR. Oh, filter ADSR, set downs. So this is going to be reverb dot get right. It's going to be LFO1 dot get bottom. Then the width and the height of this should be the same as the LFO1. So 180. 160. Yeah, you're right. A processor chain would probably be the way to go once it gets to this certain point, for sure. Especially if you want to be able to actually change the order of components. ADSR components. There we go. So I don't know if this is going to work because I haven't actually created stuff in the processor value tree state. Let's try it. It'll probably say, no, you don't have this parameter. Yeah, see, it's cool. It's cool though. We could create those quite quickly. So, okay, so now let's go to, let's create this. So we're just going to copy all of this. Just going to add filter like that. do filter. Yeah, whoosh sounds good. I think there's a plugin called whoosh though. I should make a graphic design for it. That would be cool. And then let's see here. So ADSR. So now we need to have another ADSR. So let's see. So we need an ADSR data. So where is the ADSR data so where is this at? Ah, it's in the voice. Okay, cool. That's no problem. So, okay, so I will create another ADSR that will be in here. So let's do I have ADSR data? So let's do hashtag include data, ADSR data. So this is my own class of ADSR type. Oh, is that right? So set parameters. Yeah, just have, yep, so that's fine. So go back. Yeah, so now we just need to make an ADSR data. So ADSR data, filter ADSR. And then we need to do prepare to play, all of this. Filter ADSR, repair, or what's it called? Prepare? What is that called? ADSR set sample, so it's just set sample rate. Set sample rate. Sample rate. Oh man, I don't know about that. They've got some people who are pretty stellar on synth making. I'm just a novice. That would be sweet though. So now how are we going to do this? We need to apply the ADSR. Oh boy, now we're going to get back to this thing again. Kind of back to where we began. Which is going to be something like, so you got filter, set params. So where's filter dot process next sample? That's it. So I think it's something like this. Filter ADSR get next sample. Something like that. Oh man, output people are the best though. They're really good at what they do. I can't say anything about the course, but I think I mean, they're some of the best in the business, aren't they? What am I doing here? So set filter params. And then I need to do something like filter ADSR set parameters. No, that's not quite right. Filter ADSR update. That's what it is. Update. So we got this. Yeah, this should all probably go in a whole class and a whole thing of its own. Auto and filter attack equals all of this. I'm just going to call it attack. Then we're going to do decay, then sustain, then release, decay, sustain, release, attack, decay, sustain, release. Yeah, there's some stuff in here that I should probably do that I haven't actually done. Like I should have like a reset function that resets the DSP, that sort of thing. So, okay, so filter.getNextSample is going to just thinking how much of the filter it's going to apply to. I think it'll be fine. We'll try it out. We will try it out and we shall see. Yeah. Is it doing something? Did it fail? Oh, I didn't actually hit build. Okay. If you're looking at getting something that has really cool guidance, I think one good one is Hack Audio. Hack Audio. They have who's by this guy Eric Tarr. He's got some great stuff. Oh, where's my? Oh, it's down here. I don't want it to be down there. I want it to be over here. Okay, so let's go back. Let's do back to the plugin editor. So this should be LFO. So why is it below my reverb? What's going on there? Does it need to go like this? because it's not going to know what the right position of the reverb is at that particular moment. Actually, I'm just going to build it in standalone here for a moment. Yeah, Hack Audio is awesome. I mean, this is a bit janky, but it's not too bad. So what's the reverb? Let's do 150. Yeah, it's okay. Move these sliders up. Oh, but then that's going to mess this up. Okay, let's see if it works first, and then I can go back and correct it later. Yeah, Hack Audio is really good. He's like a proper DSP person as well, so he knows his stuff really well. Okay, so let's try this. I got an idea. I could actually bring. Oh no, I can't bring that up. Dang it. Even if I do bring it up, that doesn't make a difference because the filter LFO is going to be the same size. Okay, let's see if it actually works though. Oh, not hearing anything. Yikes, what's happened? Okay. Cool, so I don't hear anything. What's going on? So let's go back to the plugin processor. Filter, get next sample. So I'm doing update. I feel like I haven't done something quite right with the ADSR. Let's see here. Dang, how long have I been on here? 4 hours. Holy cow. ADSR. I think this actually falls in the same category as the LFO, which is that I'm applying it in the wrong place. So going back here, so this isn't quite right. Should probably be something like this. So I think I need to do something like this. ADSR output. don't think it needs to be an array, but I'm just going to do it anyway. Wrong braces. No, not the whole thing. Come on, man. Okay. So this should be ADSR output equals ADSR filter ADSR filter. Yep, I set the sample rate. Yeah, no, it's because I'm applying it wrong. See, this needs to apply to the filter cutoff frequency, right? The only thing is, let's see. So it needs to go in here. There needs to be a depth. There needs to be a depth slider for this as well, because it needs to know how much to actually apply it to. So filter cutoffs. So then you have the LFO. So it should be something like this. So the question is, should it go before or after the LFO? So it will need something like ADSR filter depth times ADSR output. Is it output? What I call it? Filter ADSR output. Plus. Is that right? So let's see. It should really be a thing where you could only do either. Should it be only the envelope or the LFO, or is it okay to have both of them? I guess it'll be okay to have both of them. This should probably come before. I suppose it doesn't matter because it's just adding. It's just adding each one of these. So we just need to make one more thing that's called ADSR filter depth. Right. So, or else it's just going to modify it by one, which will be kind of not very useful. So where is this filter? Okay, so I'll put it right here. So where's my LFO depth? So should be something very similar to this. Filter ADSR depth. Filter ADSR depth. So we're just going to try this out, see how this goes. So I'll try it out at 1,000. DSR depth. So all of this, auto filter ADSR depth equals all of this. Filter ADSR depth. Okay. So let's try this out. Yeah, so the envelope is just going to go from zero to one, no matter what stage it is in the ADSR, right? So my thinking is that it's going to be something very similar to what we did earlier with the LFO depth, which is that you need to multiply it to tell it what frequency range you need it to go down. So you need to take that value that's going from 0 to 1, and you need to actually multiply it by how the frequency range of what you of the frequency cutoff that you want it to affect. Let's see if I'm right. Well, so this is good news that we actually have sound again. Let's get something that has some. So. I feel like I don't know, it's so tough to tell, isn't it? Feels like it's doing something. I can't really tell. I don't know. Maybe I need it to be like 10,000. The depth is at 0. No, I thought I set it. Filter ADSR depth. So I'm going to do it to like 10,000. Let's just make sure that I've got that right. So we got ADSR output. Do I got 2 ADSRs? No, I think that's fine. Yeah, we'll give that a shot. Altanis. Yeah, we'll try seeing what the deal is with this. So once again, we'll put on stall. No, it's not quite right. Okay, so let's go back here. DVG. So let's console out what filter ADSR depth times ADSR output. So we're just going to console this out, see what we got. Okay, so TP Synth. So I'm just going to bring this over here so we can see what's happening. So it doesn't seem to be doing anything. So there's nothing that's okay. So let's go back again. So I'm just going to cancel that for a moment. Filter ADSR, get next sample. Okay, so let's try this. See if we're actually getting any information from the ADSR itself. If it's just doing nothing at. Let's try this. Just have it in the other screen for now. Yeah, it's making sound, but it's actually not. It's not actually outputting anything from the ADSR output. Okay. It's because there's nothing that's telling it. There's nothing that's telling it to start. That's why. Nothing tells it. Nothing's telling it where to begin and where to end. Because, yeah, we don't have a start note and a stop note, basically. No specific reason for building VST rather than AU. It's actually building. Yeah, I could actually build it for AU just as easily. It's no problem. But yeah, you have to have a filter ADSR start note and stop note. So now the question becomes, does this need to be in the voice? Because it's in the voice where you signal start note and stop note. See, ADSR node on, ADSR node off. That's what detects when you actually start and stop it. So now it's a question of if it needs to be in the voice, and then I get the value, then I pipe the value out from synth voice into. That's what I'm thinking. I'm thinking that's what I'm thinking that's the way to do it. But I'm going to have to change some things around, though. Yeah. I'm gonna have to change a few things around. Just trying to find out how does it actually set. Do I have a getter? Yeah, that's it. So we will do this. Actually, it shouldn't take too long, actually. So we got this. We will put this in the voice. We will do another getter. Should be filter, so ADSR data and get filter ADSR return filter ADSR. Now we just need to bring all of our stuff from here. So we got filter. So now we just need to do a few things. So how are we updating? Oh, it's cool. I think it's fine. The only thing is I want to do this up here now. Do I? No. Let me think here. Yeah, this needs to be here. Yeah, of course it's going to be the same name. So we got filter. Because this resides in the voice now. Decay. Filter. Sustain. Filter. Release. Filter. Attack. Decay. Sustain. Release. So this will go all here, like this. Then this will need to be auto filter ADSR equals voice get filter ADSR. Great. Nearly there. So this will actually, let's think about this. How, so this would need to happen in the voice. It doesn't need to happen in the voice, but to keep it clean probably needs to happen in the voice. And then get it from, then, oh man. Let's think about this. So let's put that. Just trying to keep it as clean as possible, even though it's starting to get a little bit. let's see here. So this would need to be okay, I'm going to do something like this. Filter, ADSR, get next sample. And then I'm going to set it equal to a member variable that's going to be accessed. Yeah, exactly. Yeah, so I'm just going to do it here in the voice and just access it through the audio processor. So it would be ADSR filter, ADSR sample, or output. Then I'm going to do a float. 0.0. And then I'm going to do this, float, get filter ADSR output, return filter ADSR output. And then we need to do, of course, the whole reason that we did this whole thing, we need to do filter ADSR dot note on filter dot ADSR filter ADSR note off. Okay. I feel like that's fine. And then we just need to put that into the processor. So let's see here. So this would be something like I didn't want to do all this again. Shall I set a member variable here as well? Oh, see, I already have ADSR output. This actually just doesn't, this just needs to be a float. Doesn't need to be, actually, I'll just leave it like this. It's fine. Oh, no, I can't. I can't because it's not going through a, so ADSR output. Here we go. Nearly there. ADSR output. Okay, ADSR. And then we go back out here. This would be at the very end of this. ADSR output equals filter ADSR. Get, oh no, voice, get ADSR, get filter ADSR output. Okay, cool, so we got that. Don't need an individual one for each channel. there's probably a, oh no, what happened? Filter ADSR. Oh yeah, I need to bring this back over here into the voice. Where is this? Select this. Yeah, there's probably a cleaner way to actually do all of that, but yeah, I'll need to check it out. See, clean it up at a certain point. Okay. So hopefully this won't blow our eardrums up. So yeah, once again, just turn down your headphones, headphone check, and all of that. Okay, now I'm just going to turn this down, turn the attack up. So, okay, so it's not working. I think it might be my ADSR. I think it might be my ADSR depth. Yeah, I think it might be my ADSR depth. It's doing something though, because but it'd be a lot more useful if I actually had a saw wave here. Okay, so let's try this. Okay, so it's doing something, but it's opened it all the way back up. So do I need ADS? So I guess the question is, do I need ADSR, the depth of it? It needs to know how much it's actually, what the range is. So question, why do you use array instead of audio buffer float? For what? For what, like this? LFO output? Yeah, because it's just, this is just the number of channels to process, which is 2. So it's just, I could do a C style array, something like this, like float, put like that. I could probably do as well. So like that'd be the same thing, more or less. Yeah, I tried bringing it down to make it plucky. It's not there. I think my depth is too much. So let's try this. I should probably see what the ADSR output is. That's not going to work though. Hold on, let's just stop, because I already know that's not going to work, because ADSR output is going to be 0 to 1. That's going to be 0 to 1. That's just going to add to the filter cutoff, which is just going to make it, if it's at 20 hertz, it's just going to make it 20 21 hertz. That's not what we want, is it? Let's just make sure that, let's actually just make sure that the output is actually outputting the values that we want. So we should see the ADSR output going from 0 to 1 and back to 0 eventually. So let's try this. So I'm just putting the synth in a different window here. So it's still 0. Okay, so it's not actually outputting anything still. Okay, so that's a problem. That's a big problem. So chances are my this is fine. So let's go back, see what is actually happening. So I'm going to comment this out for a moment. I'm actually going to go to the voice and see if so let's go to the voice, and I'm going to take a look at this line. I'm going to take a look at this line here, see if, so I'm going to do filter, DBG, filter, ADSR output. Okay, so let's just try that there, see if it's actually, because we're doing node on, doing node off, setting the sample rate. Should be working. I'm just going to comment this out here so we don't, we'll get some discontinuities. So we should be seeing the ADSR outputting numbers. I remember actually having an issue with ADSR get sample, but let's see what happens here. Oh no, it is actually outputting. Look. Oh no. Oh, I need to go back to my window. So it's ramping up. What's up with that? Is that right? Oh, it only happened. Okay, so what in the world is it doing? Oh. What to make of that? So it's outputting, but it's just steadily increasing. Why is it doing that? Okay, where are we? Okay, so one big problem is that where are we setting the ADSR at? So we're setting it in our processor. So let's go back down here. Okay. Let's see here. So filter attack. So where does ADSR get actually applied to? That would happen in this process block, right? Where do I actually apply that at? I think I do it in voice, actually. Apply envelope to buffer. Get next sample. Return the next sample value for the. Give what a go. It's not really, it's working, but it's not the right values. Why is that? It's just steadily increasing. Why? Why is that? Don't really understand that. It's node on, current state, state attack. No, because it's just the same thing. It won't matter. Yeah, it's not that the ADSR is flawed. It's that I'm getting the information wrong. It has something to do with get sample. Thing is that get sample is get next sample should be happening on a per sample basis, shouldn't it? Whereas the buffer is happening per buffer, is happening in buffer size chunks. And now the problem is the values that I'm getting from the actual ADSR. So just the ADSR itself isn't quite right. So here's the problem. I'm expecting filter ADSR dot get next sample to return to basically ramp up quickly to 1, and then as long as I'm pressing the key, and then when I release the key, go back down to 0. When instead what's happening is that I'm pressing the key, and as I press the key, it's just steadily increasing the value of the sample. It's like, why is it doing that? Yeah. Strange. Theoretically, whenever I press it, it should just ramp up quickly to 1. Oh, thanks a lot. Dude, is your synth available? Can we see it on GitHub? Filter ADSR, get next sample. Is it because I'm not actually applying it to anything? I'm not applying it to a buffer or something. I would think that I don't. Let's just try this. Let's just try ADSR, get next sample. Just see if that outputs the right values. I'm wondering if it's because I'm not applying the envelope to a buffer. Let's try this. Yeah, see how that ramps really quickly up to 1 and then goes back down? Oh. See that? That is what we want. I'm pretty sure that the reason that it's doing that is because I'm not actually applying the envelope to anything, actually. Should be like something like, so let's change this back to filter ADSR. So maybe it's something like filter ADSR, apply, process. So can you do a process on a sample by sample basis? Filter ADSR? Let's try it. So let's see here. Get next sample, apply envelope to buffer. So it's only, so you can only apply it. You can only apply it to a buffer. Maybe I'll just give it like a dummy buffer. What if I do this? I've got an idea. What if I do this? Da, da, da. I'm gonna do it at the very beginning before I actually I'm gonna do something like this. Filter, ADSR applied envelope to buffer. So basically I'm not getting the correct values out. Num samples. Is that right? Synth. Get num samples. Okay. Nearly there. So this is what I'm going to do. Set the size, which I actually shouldn't be doing technically in the process block anyway. Apply it to the buffer and then clear it out. Like get the value. Okay, this should work. This should work. So here we are. So now we should get a value going from 0 to 1. There we go. All right, cool. Now we got our values coming in through there. Now we go back here. So let's make sure we got filter ADSR output. Yep. Okay. So now we go back to plugin processor. And then let's see what filter ADSR output is. A tutorial on fixing memory leaks. My best tutorial that I could give you on that, so I'm not an expert by any means on anything like that, but one thing that I would say is use smart pointers. Don't use raw pointers unless you absolutely have to. And that will save you from a lot of memory leak problems that you'll have. So where are we? So what are we doing here? So, okay, so we're trying to console out the ADSR output. So hopefully ADSR output will give us some values. So here we go. So we're back in Ableton. And I'm going to open this up in a separate window, see if we can console this out. Okay, for some reason, ADSR output isn't getting the right value. What's up with that? Return filter ADSR output. but I have it. Then here I have filter ADSR output. Huh. So what's happening there? Can I do this? Maybe. Filter ADSR. Get next. Let's try that. Okay. Dang, it's 11 o'clock over here. I've been on this live stream for like 5 hours. So strange. Why am I not getting an output from here? So we have ADSR output. Set voice params. So where am I calling set voice params? Yeah, from set params, which is getting called in the process block. Doing something very dumb here, and I can't figure out what it is. Getting the voices. Each one of those should have a filter ADSR output object. In the voice, I have a filter ADSR member. So strange. Maybe I need to do voice. No, that shouldn't make a difference. So weird. Yeah, I hear WDL is good. That's on Linux, right? Weird. Why is it doing that? Dang it. Why? Why, man? Why? What is going on there? I have no idea why it's not getting the output from the voice. What is going on here? So strange. Okay, let's try a different approach. Let me just, let's see here. Synth. So I really don't know why that's not working. I really don't. Let me just try this. So strange. Okay. Ah, yes, I know why. I know why. I get it now. If you have this synth has 5 voices. If you have 5 voices, but you're only playing one note, it's only going to look at the ADSR, the first note. All of the other ones are going to be 0, right? That's why. So it should be, so, okay, so like, let's take a look at this. Synth, should I just do something like this? Let's try this. So what's synth? So let me try this. Synth, get voice, 0. What about that? Okay. Feel like I've got it. I feel like I've got it. Is anybody actually still watching this live stream? Oh yeah. Now we got it. Fantastic. Okay. There we go. Can y'all hear my dog snoring right now? Absolutely hilarious. Cool. Y'all still with me? Here we go. We're here now. We have arrived. So I don't even need that in here. So this can actually go like this. So I could do this. This doesn't need to be a member variable anymore. Cool. So this should work. I'm trying to think of any reason why this would not work. She's hilarious. All right, here we go. All right, this is the true test. This is supposed to be a quick one. All right, here we have the synth. It changes to saw wave. I think I hear some. Only thing is, I hear it doing something. Yeah, nearly. Filter ADSR depth. Let's just make this like 200. Oh, this needs to be, go back. This needs to be a float. Yeah. You did call it. You did say 3. All right, let's try it. We got through a lot though. Okay, weird. It's not even showing that there. Oh, I'm pressing the wrong key. Dang it. Hmm. Is it just this? Is it just ADSR output? Let's think about that. If it's ADSR output is going, so I thought that this would be something very similar to LFO depth, where you have this depth and that it would go. Yeah, so let's do this, right? So auto output equals this. We're just going to pull this back to normal, and then we're just going to see what output is. Okay. Let's see what the output is. 1 second. Yeah, so it's going from 0 to 200. So that's doing what it's supposed to be doing, as far as I can see. So now let's try this. Oh my goodness, I've just seen. No, never mind. Thought I saw something. All right. We're nearly there. I swear it. We are nearly there. Okay, so when I pull this filter down, it should be going up to 220. Yeah. Okay. Then we'll just change this. Okay, so that's doing what it's supposed to be doing. Is it maybe because I had the LFO depth? Ah, it's because I had the LFO depth along with it. The LFO depth was maybe, I don't know, actually. Okay, so let's. Uh-oh, what's happened? Okay, so now this should work. Let's get something. Still not quite right though. What's going on here? I can hear it doing something. Those set params. Filter cutoff. Okay. If I do this. Interesting. It's not doing anything now. It's not even taking in my MIDI. What's going on here? That's strange. Not sure what happened there. Okay, so let's try this again. Huh, why is it doing that? It's because I have this. Is it because I have this? Oh, I'm pressing the wrong freaking button. That's why. Oh man, it's getting late. All right. I think last one. Last one, and then we'll call it a night. This is a good session though. Right? Okay, so now, so why is it going, oh no, that's not what we want. So it's doing that same thing again where it's like just continually increasing. Okay. It's a good place for us to stop, I think. It's not quite there. Yeah, it's not quite there. It's can't figure out why there's something that's happening there. But yeah, it's a good place. Good place for us to call it a night, I think. So I'm actually going to push these changes. Add, git commit, added LFO to filter cutoff, working through envelope to filter cutoff, but getting errors. Push -u origin main. Boy, that was a marathon. That was a marathon coding session right there. Yeah. Yeah, we got pretty far though. Yeah, the LFO. I think we got some really good functionality. So we can let's end on a high note, showing what we've actually done, stuff that actually works. Here it is. We're gonna take a victory lap. Let's take a victory lap. Here we go. So now we got this. Let's get, that's dubstep right there. Let's get some. Oh, we need to get some. We forgot about the reverb. And then we have the, what else do we got here? Oh. Pretty epic sounding. Let's get some more release there. Yeah, not bad at all. That's pretty cool. The freeze theme. The freeze is pretty cool. Haha, nice. Pretty cool. Yeah. That makes I think I'm deserving of some food now. Yeah, that was nice. That was a good coding session there. Cool. Thanks to everybody who hung out, especially people. There were some people who have been hanging out for quite a while. Aldonis, great meeting you. Thanks for hanging out, and yeah, come and hope to see you all again soon. Hope you're having a great Friday wherever you may be in the world, and that this session has been helpful for you. And yeah, we will see you next time. Hope to see you next time. And yeah, be sure to join our Discord as well on theaudioprogrammer.com/community as well. We always connect on things like this. And I will see you soon. Have a great night.